The Chemistry Behind Fireworks by Colin, Dakota, and Matt. How do fireworks relate to chemistry? Well, we found out that there are several different ways. One of the ways that we're going to talk about is colors, how the different colors form in a firework, and that's because of chemical reactions, and then the chemical compounds in fireworks that make up fireworks and make them actually work, and that's what they're built on. Well, Dakota's currently at IHOP right now working, so we'll let him snake out of this one. I'll cover for him, but here's a great picture of him. For people who don't know what's in a firework, first off, you're going to have the shell of a firework, then you're going to have the compounds in it created that are going to be your colors, so you can have several different, if you want a several different colored firework, and then you're going to have a fuse, and at the bottom is going to be black powder, which is going to be the explosion that makes the whole firework blow up. To make your compounds and to get different colors, they're all going to be different compounds to create each. So for red, it's strontium chloride. For green, it's copper chloride. For silver or whitish, it's potassium perchlorate. Different chemical elements heated to high enough temperatures emit the energy at specific wavelengths. Depending on the element and heat applied, different colors will be given off. Scientists normally test this with these factors in labs before they put them in the actual fireworks, so they'll form the compounds several times and then ignite them in the lab to see the colors formed before putting them actually in the fireworks. Well, see, I have no way of communicating with my good friend Matt. So now that it's a weekend, kinda won't see him till Monday when we're presenting, so I take it upon myself to complete the job, finish the mission. So that's what I'm doing. To make a compound that you can actually use in a firework, you'll need a few things. The first thing is you're going to need an oxidizer, and then plus fuel, and then whatever ingredients you add to that will give you your color. So an oxidizer is an oxygen-rich substance. Some examples of oxidizers are potassium nitrate, potassium perchlorate, strontium nitrate, and then you're going to need fuel to combine with the oxidizer. Some examples of that are sulfur charcoal, aluminum powder, magnesium powder. And then you're just going to need whatever you need for the colors, which you can form separate compounds to that and then just add it to it. Fun fact, blue is the hardest color to form in a firework. You need perfect chemistry. Here's a little overview of everything we talked about and some more information that I didn't get to. Fireworks generate 3 very noticeable forms of energy: a tremendous release of sound, bright light, and heat. The tremendous booms heard at ground level are the result of the rapid release of energy into the air, causing the air to expand faster than the speed of sound. This produces a shock wave or sonic boom. The colors are produced by heating metal salts such as calcium chloride, sodium nitrate that emit characteristic colors. The atoms of each element absorb energy and release it as light or specific colors. Yay!
Nice. Nice.
Mark's an idiot.
Say hi.
God dang it, Mark.
That's why he's an idiot.
Down syndrome. So do I get my 100 now, or do I have to pick it up somewhere? What's the deal behind that?
Or you send it to me.
Yeah, just put it in Skyward, I guess, and we'll be good.